When performing any calculation with numbers that describe real-world quantities, it is very important to keep track of units. For instance, if you wanted to drive from the Hayward Hills campus of Cal State East Bay to the Concord campus, Google Maps could tell you that your drive would take approximately 40 minutes to 1 hour. It could also tell you that the distance you would have to drive is 34.1 miles. Minutes and hours are units of time. Miles are units of length, and it is important to specify them. If someone asked you how far you were from the Concord campus, and you just said about 30, it wouldn't be very informative. You would need to specify whether it's 30 feet, yards, miles, unless it were clear from the context. When performing scientific calculations, always specify the units for all quantities. Of course, many quantities can be expressed in different units. For instance, time can be measured in seconds, minutes, hours, days, weeks, months, years. To convert between these quantities, we need to know how they are related to each other. For instance, 1 hour is 60 minutes or 3600 seconds. Therefore, 2 hours are 120 minutes or 7200 seconds, and a half hour is 30 minutes or 1800 seconds. Similarly, length can be measured in inches, feet, yards, miles, as well as centimeters, meters, kilometers, and so on. We know that 1 inch is 1/12 of a foot, or 2.54 centimeters. Therefore, 6 inches is 6/12 or 1/2 of a foot, or 6 times 2.54 centimeters, and that is 15.24 centimeters. As we have already said, only quantities expressed in the same units should ever be compared. Scientists around the world use the International System of Units, also known as the SI system. This system starts with defining the units for 7 quantities. The SI unit of length is the meter, equal to about 3.281 feet. The unit of time is the second. The unit of mass is the kilogram, equal to about 2.205 pounds. And the unit of amount of substance is the mole. We will talk more about what this is later in the class. The other 3 base units defined in the SI system are the Kelvin for temperature, the ampere for electric current, and the candela for luminous intensity. We won't concern ourselves with these latter 3 quantities in this course. The table on the slide shows the 7 base units of SI and their standard abbreviations. As we said earlier, the magnitudes of the various quantities that we encounter in science vary greatly. That is why the SI system also defines so-called metric prefixes. You can see a table with the metric prefixes and their standard abbreviations on the slide. Each metric prefix denotes a power of 10. For example, a kilogram is 1000 or 10 to the third power grams. You will often find masses in grams or kilograms on food packaging. A nanometer is 1 billionth or 10 to the power minus 9 of a meter. Modern computer chips have parts with sizes of only a few nanometers. An attosecond is a billionth of a second, or 10 to the power minus 18 second. Some processes inside atoms occur on timescales of a few attoseconds. The base units in SI can only be used to measure 7 quantities. What happens if we need to measure something else? In that case, we need to use so-called derived units. To understand how they work, consider speed. We said earlier that the distance between the Hayward Hills and Concord campuses of Cal State East Bay is 34.1 miles, and that you can drive from one campus to the other in approximately 40 minutes if there isn't much traffic. What then is the average speed of someone driving between the 2 campuses? Pause the video for a moment and try to calculate it. To answer this question, we need to define speed first. By definition, speed is the distance traveled per unit time. So if a car is moving with constant speed of, let's say, 60 miles per hour, it will travel 60 miles in 1 hour. How far would the car that is moving with the speed travel in half an hour? If the speed is always the same, it will travel half the distance traveled in 1 hour. 60 miles per hour times 1/2 of an hour is 30 miles. How far would it travel in 2 hours? 2 times the distance traveled in 1 hour. 60 miles per hour times 2 hours is 120 miles. In general, the distance that a car moving with a given speed travels within a given time interval is distance traveled equal to speed of car times time en route. This expression relates the distance traveled, the speed, and the time en route. It allows us to express any one of the three quantities if we know the other two. For example, if we divide both sides of the equation by the time en route, we will find that speed of car is the distance traveled divided by the time en route. Therefore, if you know the distance traveled and the time en route, you can calculate the speed of the car. In our example, the car travels a distance of 34.1 miles in 40 minutes or 2/3 of an hour, so the speed of car is 34.1 miles divided by 2/3 of an hour, and that's 51.15 miles per hour. Miles per hour is a unit of speed. It is a derived unit. That is, it can be expressed in terms of the unit of distance, mile, and the unit of time, hour, using the relationship between speed, distance, and time. When we divide the distance in miles by the time in hours, we get some number, in this case 51.15. By dividing the numerical value in the numerator by the numerical value in the denominator. The units in the numerator, in this case the units of distance, miles, are also divided by the units in the denominator, in this case the units of time, hours, to get the unit of speed, miles per hour. If we use the different units of distance, say kilometers, and the different units of time, say minutes, we could use the same relationship between speed, distance, and time to derive a different unit for speed, kilometers per minute. As you can see, although the units of distance and time that we use are different, in the unit of speed, the unit of distance is still in the numerator and the unit of time is still in the denominator. To obtain the SI unit for speed, you would need to divide the SI unit of distance by the SI unit of time. Pause this video and try to figure out what the SI unit for speed is. Hopefully, you found that it is the SI unit of distance, meter, divided by the SI unit of time, second, or meter per second. The units of all physical quantities, that is, all quantities that describe features and processes in the real world, can be expressed in terms of the base SI units. To obtain such expressions, you need to know the relationship between the physical quantity of interest and the quantities for which the base units are defined.